Hello, my name is Nana, and today I'm going to walk you through my project. In every bathroom, you likely find a soap, lotion, or shampoo bottle that uses a pump mechanism to dispense liquid. These bottles are something we all use, but there is an issue with them that I'm sure many of us have experienced. There's always some soap left at the bottom of the bottle that you can't seem to get out. Now, at first glance, this might not seem like too much of an issue, but for a broke college student, you realize that that little soap eventually leads to wasted money. As you can see, I am currently experiencing this problem myself. I have all this soap here, which could probably last me for about a week, don't quote me on that, but I can't get it out. People online talk about this problem too. Here is a very extensive list on Reddit, some going as far back as 10 years, and some being as recent as 46 days, talking about this issue. So, for my project, I set out to improve this pump mechanism to ensure that all the soap in the bottle gets used. Let me first explain how a typical pump works. All pump mechanisms follow the same basic principles, and it's a bit counterintuitive that pressing down on the top pushes the liquid up. Here's how it works. When you press the top, it moves the piston down into the bottle, pushing the liquid in the housing either up or down. However, a spring-loaded glass ball and funnel below the piston act as a one-way valve, preventing liquid from going down. So when you press the pump, the liquid goes up through the tube and out of the nozzle. When you release the pump, the spring pushes the piston back up and the liquid gets pulled into the housing from the dip tube below, preparing the pump for the next cycle. Now, the problem we all face is that the straw doesn't reach all the way to the bottom. So when you get near the end of the bottle, there's still a lot of soap left. But that space is needed for suction because you can't simply extend the straw all the way to the base, otherwise the pump wouldn't work. So how do we solve this? My idea is to modify the design of the bottle itself. The key is to add a protrusion or slot at the base of the bottle that allows the straw to reach all the way down without needing any extra space. The straw can still have that essential suction gap while also pulling up all the soap from the bottom. This modification would involve adding a small channel at the base of the bottle that connects directly to the straw, allowing for full dispensing of the liquid inside. The soap would be directed into the straw through the small channel, making it more efficient for the user. This design is inspired by cups with inbuilt straws, also seen in sippy cups, that allow you to get every last drop, and I've adapted that for the soap dispenser. So as you can see in these card models, the straw enters the circular slot from above, and it has another slot at the base of the bottle. So it essentially creates an extension of the straw that goes sideways. When you press on the nozzle, it's going to suck up the air. And with the tolerances between the top hole and the straw being adjusted so that they'll fit perfectly, you essentially are able to suck up the soap from the hole at the base. Now let's talk about how this design can be manufactured. The bottle itself would continue to be made using blow molding, which is the process typically used to create hollow plastic items like soap bottles. In blow molding, a heated plastic tube called a parison is placed into a mold and air is blown inside to expand the plastic until it takes the shape of the mold. This allows us to create the hollow body of the bottle. Now, since we are using a mold, we can add some modification to the already existing mold and include that modification to the base that allows us to insert the straw. Alternatively, the hole for the straw could be made with injection molding, which might involve a little bit more, but creates a much more steady part. It is also a cost-effective process, making the modification practical for large-scale production. For the materials, we will continue using high-density polyethylene for the bottle and the adjusted base, which includes the extended straw. It is used generally because it is durable, lightweight, and resistant to chemicals. And so we wouldn't be adjusting the materials that we would use. So, what are the pros and cons of this design? The most obvious benefit is that the user can get all the soap out of the bottle, reducing waste. It uses existing manufacturing processes with minor adjustments, so it's still cost effective. And thirdly, the experience for the user becomes much smoother, avoiding the frustration of leftover soap. Another consideration with this design is its environmental impact. By ensuring that all the soap in the bottle is used, we reduce waste not only in terms of the soap, but also in how often people need to replace bottles. Fewer replacements mean less plastic waste. Additionally, since the materials we are using are both recyclable, the design can fit seamlessly into a more sustainable and eco-friendly lifestyle. Soap dispensers could even be reused with this design, helping reduce overall plastic consumption. The disadvantages are that it adds a bit more complexity to the mold, particularly with the new slot for the straw at the base, and the straw would also need to be customized to fit this specific design, so it might not be universally applicable. However, I believe the added satisfaction and reduced waste would make this design worthwhile for both the manufacturer and the end user. Looking at broader applications, this design could be appealing to companies that manufacture personal care products such as hand soap, shampoo, or lotion. Brands that prioritize sustainability and user satisfaction could see the value in ensuring that their customers get every last drop of their product. For instance, companies like Method or Mrs. Myers, which focus on eco-friendly products, may find this design beneficial for aligning with their brand values. Partnering with such brands could be a way to bring this idea into the market. In conclusion, this project tackled a widespread problem that affects a lot of people. I used SolidWorks to design the card model, and I gathered information from several sources, including stock videos and Reddit discussions, to inform my solution. Thank you for watching, and I hope you found this project useful.